All right, let's dive in. Today we're talking about one of the most fundamental and maybe one of the most mysterious forces in the universe, vibration. We're going to go on a journey from ancient legends and the hidden patterns that sound creates, all the way to the very edge of physics and the fabric of reality itself. So let's get into the hidden power of vibration. Okay, so picture this. We start with a story that sounds, well, impossible. It's an eyewitness account from Tibet describing monks levitating giant stones with nothing but the power of sound. This quote right here, it captures this unbelievable moment when a multi-ton block didn't just lift, it actually sped up as it flew through the air. And that incredible story just forces you to ask, right? Can sound really do that? Is this just an old myth, or is there some kind of lost science going on here? Could something as simple as vibration hold the power to move the world in ways we're just now maybe starting to understand again? To even begin to unpack that, we need to start with something we can actually see. We need to look at how sound can physically affect matter on a scale that we can measure. We're going to make sound visible. So, there's this really cool field that studies this, and it's called cymatics. It is basically a way to see the hidden architecture of sound. It shows how sound waves can organize physical stuff like sand or water into these incredibly complex, beautiful geometric shapes. So check this out. When you play a specific frequency through water, you get this amazing, stable geometric pattern. Now, this isn't random. The vibration is literally organizing the water molecules, giving them a coherent structure. And if you disturb it, yeah, it breaks into chaos. But here's the wild part. The order is still there in the vibration. As soon as the water settles, the sound just recreates that perfect pattern all over again. It's a direct, visible example of order being born from pure vibration. And it's not just simple, clean tones. When we take something way more complex, like the song of a humpback whale, and visualize its frequencies, the result is just breathtaking. You see these ridiculously intricate forms come to life. Patterns that, and this is amazing, look a lot like the geometric structures you see in some of the earliest life forms from our own oceans. Okay, so we know for a fact sound can shape water and sand into these intricate patterns. But that brings us right back to our big, crazy question. Can you scale that principle up, way up? Can it move something far, far heavier than a few grains of sand? Let's jump back to that story from Tibet. According to this account, the whole thing was this incredibly precise ritual. A huge block of stone was put into a specific bowl-shaped hole in the ground. Then, monks and musicians surrounded it in this very specific, carefully measured arrangement. They would start a coordinated chant, with their voices backed up by drums and these long trumpets, and after just a few minutes of this focused sound, the stone would just rise. It would float up into the air, traveling in a perfect arc to a ledge hundreds of meters up on a cliff face. So how in the world could that possibly work? Well, the key might be a principle that you already know, even if you don't think about it: resonance. It's just like pushing a kid on a swing, right? You don't just shove them randomly. You push at the exact right moment, at the peak of the arc. You're adding energy at the system's natural frequency. So here's the thing. If those monks could somehow find the precise resonant frequency of that stone, they could theoretically pump focused sound energy into it, push after push after push, until its own vibration became so powerful it could actually overcome gravity. Okay, so if sound can resonate with something massive and external like a stone, what about the world inside of us? Let's shift focus and see how these same ideas might actually affect our own biology. And this is where things get really, really fascinating. Back in 2002, researchers made a wild discovery. They found that the pineal gland, this tiny little structure deep inside your brain, is full of microscopic crystals. And get this, these crystals act like tiny resonators, almost like the crystal tuner in an old radio, and they can be stimulated by sound waves. And these little crystals do something totally remarkable. It's called the piezoelectric effect. Basically, when a sound wave hits them and creates pressure, they convert that physical pressure directly into an electrical charge. Sound becomes electricity right inside our heads. Now, this provides a stunning potential link between hard science and human experience. People who are in deep meditation, especially when they're using chants or tones, sometimes report seeing this internal flash of blue light. This research suggests a very real, physical reason for that. The sound vibrations could be stimulating these crystals, which then release an electrical charge that the brain perceives as a flash of light. Sound literally being transformed into light. So we've seen vibration shape water, maybe move stone, and create light inside the brain. But what if these aren't just a bunch of cool, separate phenomena? What if this is a clue that vibration is, well, the foundation of everything? To even get our heads around that, we have to go smaller, like way, way smaller. We have to ask the biggest, most fundamental question there is in physics. What are the actual building blocks of our universe? Let's just do a quick thought experiment. You take an orange, you zoom in, you see molecules. Zoom in on a molecule, you see atoms. We know an atom is mostly empty space, with electrons zipping around a nucleus. Okay, grab that nucleus and zoom in. You find protons and neutrons. Grab one of those, and you find even smaller things called quarks. For a long time, that's where the story ended. But what if there's one more layer? And that is exactly where string theory comes in. It proposes that if you could somehow crack open a quark and look inside, you wouldn't find a little point. You would find a tiny, vibrating filament of pure energy, a string. And here is the most beautiful, elegant part of the whole idea. Think about a violin string. You pluck it one way, it vibrates at a certain frequency, and you get a G. You pluck it another way, you get a C sharp. Well, these cosmic strings vibrate in different patterns too. One pattern of vibration shows up to us as an electron. A totally different pattern looks like a quark. Another one, a neutrino. All the different particles, all the stuff in the entire universe are just different notes being played on these fundamental strings. Now, this idea that everything at its core is just vibrating strings is part of this huge, grand ambition in physics, the hunt for a single theory that can explain everything. String theory didn't just stop there. It actually evolved into a much broader and honestly a way more mysterious framework called M-theory. People like Stephen Hawking actually considered it our best shot at a theory of everything, a single, elegant set of rules that could describe all the forces and all the matter in the entire cosmos. But for the math of M-theory to even hold together, it requires something that just sounds like pure science fiction. It predicts that our universe doesn't have the 4 dimensions we know, 3 of space and 1 of time. It requires 11. So M-theory really cranks things up a notch. It suggests that the fundamental ingredients of reality aren't just these one-dimensional strings. They could be other things too, like 2-dimensional membranes existing across all those 11 dimensions. The cosmic instrument might be more like a whole orchestra than just a simple violin. And this is where your brain might start to melt a little bit. The equations of M-theory don't just describe our universe. They describe this enormous landscape of possibilities. The theory suggests there could be as many as 10 to the 500th power different kinds of universes out there. That is a 1 with 500 zeros after it. And each one would be its own unique symphony, with its own particles, its own forces, its own laws of physics. And so that brings us all the way back around. We started with monks chanting, trying to resonate with stone, and we've ended up at the idea that the entire universe is this grand symphony of vibrating strings. And it all leads to one final, huge question. If we really do live in a vibrational reality, what part do we play in the music?